Good morning. I would like to discuss about operating systems concepts today. So one of the major concept of the operating system is memory management. So in memory management, operating system, the primary goal is to manage the memory efficiently so that the degree of multi-programming could be high always as possible, so that the operating system can use the swapping concept in order to maintain the degree of multi-programming. So swapping is one of the memory management technique used by the operating system. So swapping requires the movement of the user program from secondary memory to main memory, as well as from main memory to secondary memory. So if you look at the swapping concept, the process, the program which is under execution is called as a process. So sometimes in order to copy the high priority program which is waiting in the secondary memory, shall copy it to main memory. So for that purpose, the operating system has to suspend the current user process from the main memory, and it is moving back to secondary store, that is called backing store. So the process can be swapped temporarily to and from main memory to backing store in order to continue the execution. So backing store is nothing but the secondary memory storage device, the fastest disk large enough to accommodate copies of all memory images for all users. It must provide a direct access to the memory images. So generally the user program can be divided into equal sized blocks which are called as pages generally. So that is coming under the coming topic. Here, in order to copy the user program from secondary memory to main memory, as well as main memory to secondary memory, is called as swapping, as we know that. So in such scenario, the operating system uses two techniques to actual methodologies in swapping, which is called swap in and swap out, also known as the roll in and roll out. So here the rollout means the program which is already in execution in main memory shall be copied to, shall be moved to backing store, that is secondary memory, which is called rollout or also called as swap out. Similarly, the program which is having some high priority shall move to main store from secondary store. This is called roll in or swap in. So swap in and swap out are the two methodologies which are used by the swapping algorithm of the operating system concept. So generally there are some reasons to suspend the current process execution in the secondary main memory to secondary memory, because of a high priority process may be waiting in the memory for execution purpose. Then a low priority process can be suspended from the execution temporarily. Here the major part of the swap time is the transfer time. The total transfer time is directly proportional to the amount of memory that is swapped from the main memory to secondary memory. So for example, if the program size is 100 MB, then the transfer time is also directly proportional to the memory size that is swapped from main memory to secondary memory, that is 100 MB. So that is always directly proportional. So if you take the today's modern operating systems like Linux and high versions of Windows, Unix operating systems, any Mac OSs, Sun Solaris also, they are all using this kind of technique in order to give a quick response to user programs which are all having high priority programs execution. So for example, if I tell you the small case of swapping, when swapping is required. So for example, in a mobile phone, if you take a mobile phone, when suppose we are playing a game, so suddenly during the gameplay, suppose in the middle of the play of the game, suppose if you receive a call from in a network, then immediately our game is going to pause it. As long as if you receive the call and you are talking to the conversation, you are talking with your friend in a conversation time, the duration of your call time, the game is under pause. That means this program is suspended. The local gaming application is suspended temporarily because of handling the new process which is the network call. So this is a very sample example of why swapping is required, because in that mobile phone call example, the phone call having the high priority comparatively the local game application. So that is the reason why the particular process has been suspended temporarily. Likewise in mobile phone also, after your the call is ended, then automatically the operating system inside the mobile phone can able to continue the execution of the previously suspended process, that is called your game application. So it's a very simple example of how the operating system is responsible for swapping the programs from main memory to secondary memory, as well as secondary memory to main memory. So this is a very simple one of a process of swapping. This diagram explain you how the process of swapping is possible with the support of operating system. If you look at the diagram, see at the left side we have the core memory, that is main memory, main store. So always we know the main memory, always the first portion of the main memory is occupied by the operating system. So after once operating system is installed, I mean that is loaded in the main memory, then it is start copying the user programs from secondary memory to main memory. So see the main memory is divided into two parts, operating system and user space. That is systems area. The first primary part is the systems area, the second part is the user area, that is user space. Here in the user space, the OS can copy and load the user programs from backing store to main store. So if you take this step 1, that is in circle, step 1 is swap out, means the process which is already in execution is temporarily suspended and moving back to backing store, that is secondary memory. Now process 1 is temporarily suspended because the reason is in step 2 the process 2, that is P2, has to come into main store, that is in user space, that is called swapping. So as I told previously, swap in is nothing but roll in, swap out is nothing but roll out. So roll in means what? Roll in or swap in means the program that is to be copied to main store from backing store. Similarly, roll out or swap out mean that the program temporarily suspended from main memory to secondary store. So this diagram will explain you how the process of swapping is executed by the operating system by using the two algorithm techniques. One is called swap out and swap in. So now in continuation of the swapping concept, so the swapping is the process of copying the programs, user programs from main store to backing store, as well as backing store to main store. So in order to copying, the process entirely cannot be copied. Sometimes the process can be copied in terms of pages. That's why another memory management technique of the operating system is paging. So paging is another memory management technique. Here, in order to understand about the paging concept, we have to look about the two types of address spaces in the computer's operating system point. One is logical address space and other one is physical address space. So what do you mean by logical address space? The logical address space is the area that is the actual address generated by the, I mean the address that is assumed by the user or that is generated by the CPU. Generally, suppose in order to understand clearly about the logical address space, suppose my program size is 100 KB, I don't know where my program can store in main store. Why? Because the first portion is already occupied by the operating system, and then after already maybe some user programs may be under execution, they can also occupy the main store in the user space. But now I exactly don't know where my user program is going to store and available. So for that my convenience, I can treat my user program with 100 KB can start from 0 and ending at 99 KB. So that totally 0 to 99 KB is 100 KB. So this is called logical address space. Also CPU can assume like that because the user program is having the size 100 KB. So it can start from 0 index and ending at 99 KB of a size of 100 KB. So the address which is assumed by the user or that is generated by the CPU is known as the logical address, and the logical address space means that 0 to 99 range of total KB is called as address space. So similarly, physical address space or physical address mean that the address which is seen by the memory unit, that is main memory unit, that is called MMU. Main memory unit means the main store that is starting from 0 byte 2, and the size of the main memory may be 1 GB, 2 GB, or even 4 GB or 8 GB also, like that. So always the physical memory exactly know where the user program can start